Hello everybody, it's your friendly neighborhood root beer here, starting another Galois paper. That's the grade 10 written contest. This time it's going to be the Galois from the year 2007. If you'd like a copy of this contest, and I always try and take time to encourage you guys to get a copy of this contest by downloading the first link in the description and trying it out for yourself. That really is the best way to practice. So you can go ahead and do that, and I encourage you to download, click the first link, print it out if you want to, or try it on your phone or your iPad or something. But try it out, practice it under the 75 minutes that you get for this contest, and see how far you can get. See what you get right, see what you get wrong. That really is the best way to practice. So I'm going to let you pause the video and do that, and then we can come back and talk about question number 1. Good, done? All right, great. So let's talk about question number 1, and then in the next video we're going to do question number 2, and so on. So you, I would hope, have taken a look at this one. This is my first time seeing this question here. Jim shops at a strange fruit store. Instead of putting prices on each item, the mathematical store owner will answer questions about combinations of items. That's probably a very frustrating business model. Alright, so we've got 3 questions here. Question A. In aisle 1, Jim receives the following answers to his questions. What is the sum of the prices of an apple and a cherry? 62 cents. What is the sum of the prices of a banana and a cherry? 66 cents. What is the difference between the prices of an apple and a banana? Which has a higher price? Explain how you obtained your answer. Okay. So, the common fruit in both of his questions were cherry. So what I'm going to do is I'm going to give names to these prices, A, B, and C. So let A equal price of an apple, B equal price of a banana, and C equal price of cherry. It's not a coincidence that these go A, B, C. They have chosen apple and banana and cherry. Alright, so we know, or Jim is told, apple plus cherry is 62 cents. Banana plus cherry is 66 cents. We want the difference in their prices. So B minus A or A minus B. And we want to know which one's bigger. Well, if A minus B were, say, I don't know, 10, we'd know the difference in their prices. Check. That's what we want to know. We'd also know apple is bigger because we add 10 cents to the banana price to get the apple price. So, how can we get one of these two? Doesn't matter which one is which, because if A minus B is 10, then B minus A is negative 10. So we just need one of these expressions, really. Well, what I'm going to do is I'm going to call this equation 1 and this equation 2. What I can do is equation 2 minus equation 1. And we'll line it up carefully for people who haven't seen something like this before. If I line up my equations like this, I can subtract B minus A is B minus A, whatever it is. C minus C is nothing. They cancel out. And over here, 66 minus 62 is 4. So now I know B minus A is 4. So B is A plus 4. So from here, B is bigger. So I could also say, you know, B is greater than A, that sort of stuff. But we can see B is bigger. So this allows us to answer our 2 questions. The difference in price is 4 cents. And bananas cost more. Okay. I don't actually know how much bananas cost, but I do know it costs 4 more cents than apples. Alright, so that's A part. Easing us in, relating a word problem in algebraic terms so we can start solving things. That's fine. So now B part. In aisle 2, Jim receives the following answers. Some of the prices of mango and nectarine, MN, here's P for pear. So MN for mango and nectarine is 60 cents. Sum of the prices of pear and nectarine is 60 cents. Mango and pear is 68 cents. What is the price of a pear? Explain how you obtained your answer. Okay. So it looks like question 1 on this Galois is just solving systems of equations. We just need to change the words they give us into actual equations. So we're going to let M be the price of mango, N nectarine, and P equal pear. So what are we told? We're told M plus N. We're told P plus N, and M plus P. And I think the middle one was 60 cents. Yeah, 60 cents, 60 cents, and 68 cents. Okay, what are we to do here? We just want the price of the pear. That's all we want. We just want to solve for P. How could I figure out what P is? In fact, how can I get any information? Well, if we look at the left-hand side of these equations, we notice we've got 2 M's, 2 N's, and 2 P's. If we were to do the same sort of trick that we did up here and add these equations, we'll get 2 M's plus 2 N's plus 2 P's, and that's going to be 60 plus 60 plus 68. That's going to be 188. So now if I divide by 2, I know M plus N plus P is 188 divided by 2 is 94. Okay? So now we know the price of a mango, a nectarine, and a pear all added together. How does this help us? Well, we're not done yet. We want just the price of a pear. Now I have a price with a calculation with all 3 of them in it exactly once. Okay. So what we can do now is we can say, well, I just want a pear. So can I find an equation that when I subtract it, I'm just left with a pear on the one side? Okay. Is there any way to get rid of both this M and this N and keep this pear? Do we possibly have any equation that just gives us the M and the N and leaves P alone? Absolutely we do. So we can do M plus N, no pairs, is 60. And now when we subtract, these cancel, the P just sort of gets brought down. 94 minus 60 is 34. So pears cost 34 cents each. And that was it, right? We just wanted the cost of a pear. What is the price of a pear? All right. And they say explain how you obtained your answer. You don't actually have to write actual explanations. If you're uncomfortable with doing this sort of stuff, you might want to add some explanation of what you're doing, not only to keep it straight for the marker, but to keep it straight for yourself. Okay? But when they say, explain what you're doing, it's sort of show your work. The people who make these things up get a little tired of constantly saying, show your work, show your work, show your work, show your work. So they throw in things like justify your answer or explain how you got your answer. And we definitely have our explanation here. We took all 3 equations, add them up, got a brand new equation, and subtracted one of our previously known equations just to isolate P pairs. So we still have C part to do. We're going to flip the page because there's no way I can squish it down in the corner. What have we got? I think I saw tangerines. So, C. In aisle 3, Jim receives the following answers to his questions. What is the sum of the prices of a tangerine and a lemon? 60 cents. How much more does a tangerine cost than a grapefruit? 6 cents. What is the sum of prices of a grapefruit, a tangerine, and a lemon? 94 cents. What is the price of a lemon? So I think you can see, at least with my approach to this question, what are we going to do? We're going to set up an equation, or a series of equations here, involving T for tangerine, L for lemon, G for grapefruit, and we're going to add and subtract, and perhaps we'll have to multiply an equation, or like double an equation, that sort of thing, all in an effort to isolate and get L equals something, because then we'll know the price of a lemon. So if you were having trouble with this one, now that you've seen how A and B are done, feel free to pause for a second and see if you can now work out C. Okay, I'll now assume you've paused, and really you could have taken any amount of time there, but let's get to it. So T, price of tangerine. L, price of lemon. G, price of grapefruit. I suppose we probably should be writing these out in actual sentences, but don't worry too much about that. So we know tangerine plus lemon. I'm actually going to use the curly L, so I don't think it's 1. So T plus L is 60, they said. And now we have an interesting one here. How much more does a tangerine cost than a grapefruit? So tangerine equals grapefruit plus 6. Or something like T minus G equals 6. We can rearrange these equations as needed. And then I think it was tangerine plus lemon plus grapefruit is 94. Yeah, sum of the prices of grapefruit, tangerine, and lemon, 94. Okay, so this is all the information I have to work with. I want to do something and get L equals. That's what we're looking for. That's the goal. Okay. So, geez, there's lots of ways I can see to go about doing this one. Very quickly, one way would be 3 minus 1 gives me the price of grapefruit is 34. Plugging that back into 2, I know that T minus 34 is equal to 6. If I rearrange that, I'll get T is 40. And then 40 plus L is 60. I should get lemons cost 20 cents. So that's one way. I verbally explained that. But I'm trying to avoid solving for the other ones. I think it'd be fancier if I could do it without solving for the other ones. So I'd like to just get lemons. I see that there's a very quick way I could get rid of grapefruits. And that would be if I added equation 2 to equation 3. There's no shame there's no shame in having to solve for the other ones. I'm just trying to do it without solving as a fun little extra challenge to myself. 6 plus 94 is going to be 100. And I've got 2 tangerines, so 2 T's. The minus G and the plus G will cancel, and we're just left with plus L. So this is a brand new equation. We could even give it a name, equation number 4. What am I to do? Well, I've got a T and I've got 2 T's and an L. And up here in equation 1, I haven't used equation 1. And a good tip, if you're stuck manipulating equations or really solving any type of question, is to go back and reread the question and say, okay, I know this piece of information, I know this piece of information, I know this piece of information. And if you're stuck, you go back and say, oh, gee, I used this piece of information and this piece. I still haven't used the fact that the circle has an integer area. Or I still haven't used equation 1. Or I still haven't used that the sequence is defined this way. You know, look for other pieces of information you haven't used. So we've got equation 4. We got it with 2 and 3. Now, that doesn't mean we're done with 2 and 3, but we should probably expect to use equation 1 at some point. So what am I going to do with equation 1? I'm not going to do equation 1 because he's only got one L, and really the only thing I can do is subtract these. But that would get rid of my L's. It would leave me T. If I was solving for tangerines, we'd be all set. Tangerines, hey, cost 40. Didn't I say that a little while ago? What we're going to do is we are going to multiply equation 1 by 2. And it's as simple as it sounds. 2 T's, 2 L's, and then 2 times 60 is 120. Now, why have I done this? Because I've got 2 T's, and I want to cancel that out, but equation 1 only had 1 T. Not only that, it only had 1 L, and if I start trying to cancel, I'm actually just going to end up canceling my L's. So you can add equations, which we saw in B part. You can subtract equations, which we saw in A part. You can multiply an equation by a constant. You can even divide by a non-zero constant as well. So now what I'm going to do, I've got 2 T's and 2 L's. And I've got 2 T's and 1 L. I'm going to line them up this way and subtract. The T's cancel out. 2L minus 1L is just L. And 120 minus 100 is 20. So there we go. I think I've now detailed sort of 3 ways to do it. Solve for grapefruit, solve for tangerines, and solving for L himself right here. But lemons cost 20 cents. You can always spice this up by adding in sentences if you feel like just equations on their own don't justify things. If you are just going to put equations as a little tip, little word of advice, try and make sure that you're adding and subtracting equations follow some order and neatness on the page. Okay? Don't put this solution over here and this solution over here and this solution over here. And if you're going to do that, because you're a very scatterbrained person, at least put arrows connecting this, goes to this, goes to this. It makes it so that the markers can follow what you're doing, because if markers don't understand what you're doing, you have the potential to lose marks. Remember, the Galois, like the Friar and Hypatia, are written contests. And with written contests, every little thing you do can potentially be getting you marks or potentially be losing you marks. Okay? Now, this doesn't mean we need paragraphs and paragraphs explaining the theory of adding equations or substituting things in. But if you sub in a variable, if you solve for the grapefruits and said, oh, that's got to be 34, sub this into equation 2 would be a fantastic thing to write. Okay? Or sub this into equation 2 in order to solve for the tangerine cost. Fantastic things that you can just put them in there, little sentences to make it more clear what you're doing. Okay? I tend not to write those sentences. I tend to express them verbally here. Occasionally I'll write them down. But, don't just have just a whole mess of equations and then an answer at the end. You are liable to lose marks. Okay? C part was the end of question 1 there. Lemons cost 20 cents. That's what we want. So we're done question 1. We've got questions 2, 3, and 4 to go. I will be taking a look at question number 2 in the next video. So feel free to join me for that one next time. Or if you want to bounce around and look at 3 or 4, I'll have those videos up as well. Thank you as always for joining me, and I'll see you next time.